and post it as well. I want to get into 2, 3 because it is a long section, and that was pun not intended, but it is kind of a pun, and that's because we're back. We're going to go all the way back to long division. All right, what is long division? This. Hang on. I got super excited and I was like, no, that's not going to work. This is long division. How many times is 3 going to 81? Well, 3 goes into 8 twice. 2 times 3 is 6. Subtract. 8 minus 6 is 2. Bring down the 1. 3 goes into 21. 7 times 3 is 21. Subtract. You get 0. And what is that? What does this process tell me? This process tells me that 81 can be written as 3 times 27. In this problem, 27 is the quotient. That's the result of the division. Okay, 3 is the divisor. And then 81 is the dividend. Okay, dividend's what's under the division sign, or what you're dividing into. All right, so now let's carry this over to polynomials. All right, so here's a bunch of polynomials. Let's do the same thing. I have a 5th degree polynomial divided by a 2nd degree polynomial. So let's tackle it. Well, the first thing you have to do when you're doing these problems is list every term of every power of x from the highest to 0 power to make space for any zeros. So for instance, if I did 3 into 106, that 0 is in here. Even though there's no 10s in this number, I still need to keep a place for it because it's going to help me line things up, right? Same thing here. What's missing, right? Well, this is x cubed, this is x. I don't have an x squared term. So this is really, well, first off is the divisor. The divisor is x squared minus 3. That's missing the x term, right? And then this is supposed to divide into x to the 5th minus 2x to the 4th plus x cubed minus, I'm missing an x squared here, minus 8x plus 18. All right. Process is going to work very similar to the way that you're used to, the way that we just did that long division. Okay. The difference is I'm going to take the leading term of the dividend and I'm going to divide it by the leading term of the divisor. So if I come out here to the side, I'm taking x to the 5th and I'm dividing it by x squared. And that gives me x cubed. When I'm dividing with the same base, I subtract the powers, right? So what I want to do is the division here is going to leave me x cubed. Line up your quotient with the powers in the dividend, right? Notice I don't put this over here over the x to the 5th or the x to the 4th. This is x cubed. It stays over the x cubed. So then the answer is x cubed because x cubed times x squared is x to the 5th. X cubed times 0x is 0. X cubed minus, sorry, here's what I'm doing. Is I'm multiplying what I just found by the entire dividend, or excuse me, by the entire divisor. X cubed times x squared is x to the 5th. X cubed times 0x is 0x to the 4th. X cubed times -3 is -3x cubed. Now this comes in right down here. Plus 0x to the 4th minus 3x cubed. When you do this, it's always subtraction. And this first term will always zero out. We built the entire problem up so that the first term goes away. So then I have -2x to the 4th minus 0, which is just still -2x to the 4th. X cubed minus -3x cubed is x cubed plus 3x cubed, which is 4x cubed. And then I have 3 factors in my divisor, so I need 3 factors in my long division. So I bring down the next. So now I rinse and repeat. What's my new leading term? It's -2x to the 4th. What do I do with it? I divide it by the leading term of my divisor, which is x squared. -2x to the 4th divided by x squared is -2x squared. Right? So that means the next term in my quotient is -2x squared. And now I do -2x squared times x squared plus 0x minus 3, which equals -2x squared times x squared is -2x to the 4th. The 0x is not absolutely necessary, but again, it does help line things up. -2x squared times -3 is positive 6x squared. So write all that down. -2x to the 4th plus 0x cubed plus 6x squared. And then subtract. -2x to the 4th minus -2x to the 4th is 0. Remember that first term is always going to go away. 4x cubed minus 0x cubed is 4x cubed. 0x squared minus 6x squared is -x squared. Bring down the next power, or bring down the next term, and then we do it again. So now I take 4x cubed and I divide it by the leading term of the divisor, which is still x squared. It's the same term. 4x cubed divided by x squared is 4x. And then I take that 4x and I multiply it by the divisor. And what do I get? 4x times x squared is 4x cubed plus 0x squared minus 12x. 4x cubed, 0x squared minus 12x. And this is subtract. 4x cubed minus 4x cubed, 0. Great. -6x squared minus 0x squared is still -6x squared. -8x minus -12x is plus 12x. So that's plus 4x. And I only have one term left, the 18. One last time down the road. New leading term. negative 6x squared. I divide it by leading coefficient or leading term of the divisor, which leaves me a negative 6. So negative 6 times x squared plus 0x minus 3 is equal to negative 6x squared plus 0x plus 18. And what do I have? Negative 6x squared plus 0x plus 18. And I subtract. Negative 6x squared minus negative 6x squared is 0. 4x minus 0x is 4x. 18 minus 18 is 0. And I'm done. Okay. What did I find? Oh, I forgot to put those back in there. Plus 4x, and then what was the last one? Minus 6? Minus 6. Right? Well, what did we do? We just divided a polynomial by another polynomial. And this is the result. That's our quotient. All right? So these are the kind of problems. This whole section in 2-3 here, this is perfect for a video because these problems take time to do. Is everybody okay with the process of what's going on in this problem? Does everybody understand what's happening over here? I'm taking the leading term of the dividend, dividing it by the leading term of the divisor. X to the 5th divided by x squared gives me x cubed. Because I want x cubed times x squared to be x to the 5th, and I want that term to go away. Next time, negative 2x to the 4th. So the question, as you do this more and more, you may change your mind about how to ask the question. Instead of saying negative 2x to the 4th divided by x squared gives me negative 2x squared, you may start to say, what do I multiply x squared by to get negative 2x to the 4th? And that will give you the same answer. It's just a matter of, I can't write that down as easily. I can write it down when I just have leading terms. All right. So keep it going. Take a shot at these. All right. If yes, we will. So leading term, yeah, when the leading term doesn't have a coefficient, and it is the first degree, then yes, we will do synthetic. Right? But we have to show you how lucky you are to have synthetic, because we have to show you how to do it the really, really hard way. All right. Cool. All right. Any other questions before we go? No? Yes. What's up? Oh, 2.1. Question 4. Question 4. Yes, it is due tonight. All right, so consider the following quadratic function. G of x is equal to negative 2x squared plus 12x minus 11. Write the equation in the form G of x is equal to a times quantity, x minus h, closed quantity squared plus k. Gotcha. Then give the vertex of the graph. All right. So I'm gonna keep rolling on the recording. So if you do need to go, you can go ahead and you'll be able to check this video out after. Because this problem might take a minute to explain. All right. So let's steal this part. All right. So AH. Yeah. So the problem with this one is there's about what they can, and by all means, questions are great. So last class, I know we did this long division, and then I introduced you to the equation. This one was long division, and it's the first example, but it's got that the divisor has the x squared. You're not typically going to see that. You're typically going to see something more like example 2 or example 3. I have done examples 1, 2, and 3 already. But let's make sure. So let's go after example 2. I may be repeating myself, but that is completely fine. I'm dividing. Remember that this, because this comes up later, this same problem can be written like this, and it means the same thing. All right. The reason that you would want to write it like this, perhaps, is because if you don't put parentheses around the entire numerator and the entire denominator with the divide symbol, you'll get it wrong. So that's another way to write it. Notice I'm missing a term. I don't have an x term here. So I have x cubed, x squared. I don't have an x term, so I am plugging in a 0 for that. And I'm going to go ahead and start feeding you some work here. Divisor is x minus 5. Dividend 2x cubed minus 7x squared plus 0x minus 65. And so as I do this problem, leading term of the divisor goes into the leading term of the dividend how many times? Or, in other words, you can see it two ways. You either see it as 2x cubed divided by x equals what? Or what do I have to multiply x by to get 2x cubed? In both cases, the answer is 2x squared. 2x squared is the first term in your quotient, and then you multiply just like regular long division. 2x squared times x is 2x cubed. 2x squared times negative 5 is negative 10x squared. Remember, this is subtraction. 2x cubed minus 2x cubed, we knew that was going to go away. Negative 7x squared plus 10x squared is negative 3x squared. I only have one term now. Great. Bring down the 0x. X goes into negative 3x squared, negative 3x times, or I need to multiply x by negative 3x to get negative 3x squared. Is everybody okay with that? Does that make sense? Let me get the color stuff working here. Not negative, positive. All right, 7 minus negative is plus, so this is 3x squared. Bring down the 0x. I knew there's a reason I wanted to rewrite that. Well, let's try it again. So now, the rinse and repeat part, my new leading term, 3x squared. I divide it by the leading term of the divisor. 3x squared divided by x gives me 3x. Or what times x gives me 3x squared? 3x does. 3x times x, 3x squared. 3x times negative 5, negative 15x. Subtract 3x squared minus 3x squared is 0. 0 minus negative 15x becomes positive 15x. And then last term, minus 65. And last time, leading term is 15x. Divide that by x. And the result is 15. 15 times x is 15x. 15 times negative 5 is negative 75. Subtract. 15x minus 15x is 0. Negative 65 minus negative 75. Minus negative becomes plus. So this comes out to a 10. All right. Now, what's the last? How do I put all of this together? So remember, when I get done, what I'm going to be able to do is rewrite that division as multiplication, just like we did if 81 divided by 3 is 27, then 27 times 3 is 81. Same thing here. P of x is the original, and the original is that 2x cubed minus 7x squared minus 65, yeah, is equal to the divisor, which is x minus 5, times the quotient, which was 2x squared plus 3x. Plus 15. And then plus the remainder. All right, so that's long division. If I did this one last class, you may have caught me making a mistake here and making this 65 and 65 so that zeroes out. It's not. On the first set, the first video, I make that mistake on the for lecture for 2-3, but then I fix it first thing in the second part of the video, so it should be flawless. So we got another one, and then let's get synthetic division worked out. Okay. So with synthetic division, we did one of these last time. If I am dividing a polynomial by a binomial that has a leading coefficient of 1 and a power of 1, so it's pretty much got to be x, or whatever the variable is, plus or minus some number, I get to use synthetic division. All right, synthetic division it does long division, but it does it efficiently. So the first thing I have to do is figure out, if I'm dividing by x minus 2, what is the x value that I'm checking for? Well, it's whatever makes this 0. What makes x minus 2 0? 2. So 2 goes in the box, and then the coefficients from the numerator come along for the ride. 2, 13, -3. I don't think I'm missing any. -58, -20, and 24. Okay. All right, so now synthetic division, step 1. Bring down whatever that first coefficient is, because that's going to be the coefficient that begins the quotient. All right, so bring the 2 down, and then we play the game. And we take whatever's in the box here, multiply it. 2 times 2 is 4. And then we add 13 plus 4, 17. 17 times 2, 34, which is obviously why I wrote 38. Sorry. Let me get this page right back here. Yeah, that's obviously what I meant. 17 times 2, 34. -3 plus 34, 31. 31 times 2, 62. -58 plus 62 is 4. 4 times 2 is 8. -20 plus 8 is -12. -12 times 2 is -24. 24 plus -24 is 0. So that means 2x to the 5th plus 13x to the 4th minus 3x cubed minus 58x squared minus 20x plus 24 is equal to the divisor, x minus 2, times the quotient. Now, what's the quotient? The quotient is, I started out with a 5th degree polynomial. I divided it by a 1st degree polynomial. So that means the highest power in my quotient is an x to the 4th. So that starts out 2x to the 4th. And then you're just reading down the line. Plus 17x cubed plus 31x squared plus 4x minus 12. And then the remainder plus 0. You don't have to write that, but you can. All right. So I want you to take a look. Since that remainder is 0, I actually have a direct relationship between the polynomial I started with and the quotient and the divisor. So I've actually found out that if I get a remainder of 0, x minus 2 actually goes into my polynomial, meaning I'm going to end up with a set, or I'm going to end up with 2 factors of the original polynomial. And that is going to be helpful for us because all we've done up to this point is a few cubes, special cubes, and then we really focus the rest of our time on solving quadratics, solving second-degree polynomials. All right, so that said, and this is what happens when it doesn't, right? When I did 2x cubed, this one was out of order, 2x cubed minus 10x squared minus 5 divided by x plus 1, and I did that out, I ended up with a remainder that is not 0, so that means this does not go into it evenly. So I cannot write 2x cubed minus 10x squared minus 5 in terms in a set of 2 factors. That minus 17 throws everything off. So we like it when the remainder is 0 because it means we did something. It means that we actually found a factor. Now, this next page is evaluate the polynomial. The only reason we're doing it is because of a property that's going to show up. This is the last problem we just did. And so here's p of x, and I want to know what is p of x when x is -1. I do not bother rewriting the order here. You can if you want to, but it is not necessary. Powers first, so -10, 1 squared, -1 squared is 1 plus 2, -1 cubed is -1, -10 times 1 is -10, 2 times -1 is -2, minus 5 more. -10 minus 2 minus 5 more is -17. So there's my point, or there's the result. P at -1 is equal to -17. All right. Now, take a look back, because I've dealt with this polynomial before. It's right there. -10x squared plus 2x cubed minus 5. And what did I divide by? X plus 1. Meaning, what goes in the box for my synthetic division? -1. And when I do the synthetic division, look at what pops out. The remainder is -17. Well, on this page, I just showed that the evaluation of P at that number that's in the box for synthetic division is also -17. Turns out that happens every time. So what we have is the remainder theorem. The remainder theorem says that if a polynomial is divided by x minus c evenly, all right, if you divide it, or excuse me, when you divide a polynomial by x minus c, the remainder that's going to pop out happens to be whatever you would get if you took that original number and plug it in to f of x, or g of x in this case. So again, talk. How about we do instead? Evaluate g at 2. Here's g of x. What is g at 2? G at 2 is -3 times 2 to the 5th plus 2 times 2 to the 4th plus 6 times 2 squared minus 2 plus 4. Powers first because of order operations. 2 to the 5th is 32. 2 to the 4th is 16. 2 squared is 4. Multiply -3 times 32 is -96. 2 times 16 is 32. 6 times 4, 24 minus 2 plus 4. I get -38. All right. Now, the remainder theorem says if this is true, if G at 2 is -38, if I perform synthetic division by X minus C, I should also get a remainder of -38. So in this one, what we're saying, if G at 2 equals 38, comma, then G of X divided by X minus 2 will have remainder of -38. So let's do it. 2 goes in the box. Coefficients of G of X are -3, 2, 5th degree, 4th degree, missing a 3rd degree. So you need a 0 for that placeholder. 6, -1, and 4. Bring down the first term, and then let the games begin. I'll stop changing colors of pen because it's just kind of silly. Bring down the -3. 2 times -3 is -6. 2 plus -6, -4. 2 times -4, -8. 0 plus -8 is -8. -8 times 2, -16. 6 plus -16, -10. 2 times -10, -20. 20, -1 plus 20, -21. -21 times 2, -42. 4 plus -42, -38. That's exactly what we said would happen. And this theorem works both ways. You'll see that it's got 2 lines. If the remainder from synthetic division is 38, then evaluating the function at 2 gives you 38. If you evaluate the function at 2 with a binomial, then you can perform synthetic division and you'll find a remainder of 38. All right, so that's the remainder theorem. All right. And again, anything you see me skipping in here that's already done, that's on the video. And do you want to see another one of these? Do you want to see this one before we move on, or does this seem fairly straightforward? Do we need to see another example there? Okay. The next part, all it does is just use remainder theorem to evaluate the remainder when f of x is divided by each factor. So f of x is this function, this polynomial here, dividing by x plus 1, divided by x minus 3, divided by x minus 4, divided by x minus 5/2. And what that does is correspond to, well, x plus 1 is what I'm dividing by. So I'm just checking out when x is -1. X minus 3 corresponds to when x is 3. X minus 4 when x is 4. X minus 5/2 means I've got 5/2 in the box. All right. Now here's the I probably already closed it. Yeah, I was going to say. So it turns out that we have one more piece of information. All right. So we know that I can always find the remainder. And then every once in a while, I will find a remainder of 0, which means x minus 3 goes into the original function evenly. So we officially state that as the factor theorem. The factor theorem says that if f of x is a polynomial and f at c is 0, then x minus c is a factor of f of x. And the other direction works as well. If you know x minus c is a factor of f of x, then you know that taking that c and plugging it in to f of x is going to give you a 0. All right. So let's go after this next example, and then I'll show you exactly what this does or how it translates to our graph. So here's f of x. Determine if the given polynomials are factors of it. Okay, so x minus 6 is my factor. What value, or what is c here? Remember, the form here is x minus c. All right, so in this one, c is 6. Is everybody cool with that? 6 is what makes x minus 6 go to 0. So c goes in the box. Coefficients of the dividend pop in 2, negative 13, 10, negative 25, and 6. Bring down the 2. 2 times 6, 12. Negative 13 plus 12, negative 1. Negative 1 times 6, negative 6. 10 plus negative 6 is 4. 4 times 6 is 24. Negative 25 plus 24 is negative 1. 6 times negative 1 is negative 6. 6 plus negative 6 is 0. So what does that mean? All right. Well, because of the remainder theorem, we now know that f at 6 equals 0. And if f of 6 is 0, then x minus 6 is a factor of f of x. Okay? Now, I'm going to take what we just did and then write, remember the original in this one, I'm going to break it down. So now I know that f of x, 2x to the fourth minus 13x cubed plus 10x squared minus 25x plus 6 is equal to the divisor, x minus 6, times the quotient. And in blue down here below the line, those are the coefficients of the quotient. This was a fourth degree polynomial, meaning the quotient is a third degree. 2x cubed minus x squared plus 4x minus 1. All right. Questions? I'm quickly running up the graph here because I want to show you what this means for the graph. All right, so in this problem, we did synthetic division. We found out that I get a remainder of 0. That remainder of 0 lets me know that if I plug 6 in for x, I get 0 out, and that means it divides evenly. What else does this mean? Well, I said when I plug in 6, f at 6 is 0, right? F at 6 is 0. That is an x-intercept. All right? That's why this is a useful piece of information. Because if I have a higher order polynomial like this, and I don't know how to solve it, what I would do, and the way that I was taught and trained, is I would graph it. I'd go find some nice solutions on that, and then use synthetic division to break down that higher order polynomial or higher degree polynomial into, and get it all the way down to quadratics, and then we have 5 different ways of solving quadratics. All right, that's the idea here. That's what we're after, is I'm looking for a way to solve polynomials that I wouldn't be able to solve before. That's why synthetic division and long division are really helpful, because it's the only way to figure out how do I get from x to the 4th, x to the 5th, down to x squared, unless it's substitution, which isn't the case in this chapter. Okay. Now, what if I go the other, what if I just tell you one of the zeros of a polynomial, and then I ask you to solve, or ask you to find the others. So f of x is 3x cubed plus 25x squared plus 42x minus 40. And I'm given that negative 5 is a 0 of f of x. If negative 5 is a 0, that means if I put negative 5 in the box, and I do synthetic division, my remainder should be 0. So let's make sure it is. 3x cubed, 25x squared, 42x, negative 40. Bring down the 3, and then start the process. Negative 5 times 3 is negative 15. 25 plus negative 15, 10. 10 times negative 5 is negative 50. 42 plus negative 50, negative 8. Negative 5 times negative 8, positive 40. Negative 40 plus 40 is 0. So that's exactly what we thought would happen, right? Negative 40 plus 40 is 0. I knew this was going to be a remainder of 0. But what does that do for us now? Well, now f of x can be written as the divisor, and instead of writing all of f of x, that's why I just put f of x as that. That's the same thing as saying x minus c. I plugged negative 5 in and got out a 0. So negative 5 is c times the quotient. And the quotient is, this was a cubic third degree polynomial. This has got to start out 1 degree less. So 3x squared plus 10x minus 8. Make it nice here. X minus negative 5 is x plus 5. And then 3x squared plus 10x minus 8. Will that factor more? Oh, I got a quadratic here. I bet it will. Three x squared plus 10x plus 8. I'm going to do bottoms up. Which means take a and c, multiply them together. X squared plus 10x minus 24. Does that factor? Yeah. x and x, multiply to negative 24, add to positive 10. One's positive, one's negative. And then which one's positive? It's the larger of the two. Two numbers multiply to 24. It's either going to be 6 and 4 or 12 and 2. And in this case, it's 12 and 2. Remember, though, bottoms up says, great, I'm glad you found the answer. But now come back and divide by that A, because that A and C were multiplied to give you that 24. So now come back and undo that multiplication. And you'll find x plus 4 times x minus 2/3. Now, I'm fine with you leaving x minus 2/3 as x minus 2/3 because it's useful. If you want to rewrite it as 3x minus 2, you can, but just know that the next question is going to say, it's going to ask you to solve, and you're going to end up finding that 2/3 again. So here's f of x, and it's written as a product of binomials. So then they say, now solve 3x cubed plus 25x squared minus 42x minus 40 equals 0. Well, I know that entire function can be written as x plus 5 times x plus 4 times x minus 2/3. So all I did is swap out that cubic for it, the same function or the same polynomial, but it's written in as a product, as products. Why is that useful? Because now I've got stuff multiplying to give me 0. So if stuff multiplies to give me 0, one of those things has to be 0. So x plus 5 is 0, x plus 4 is 0, x minus 2/3 is 0, and solve. And my solutions are -5, -4, and 2/3. All right. Any questions? No? Just silence? That's understandable. All right. Then let's go ahead. Yeah, it is. It is. It is a lot of work. All right. So let's tackle this last problem out of 2-3. And I've got it titled as complex zeros. Everything we've done up to this point has been, I give you the function, or I give you the polynomial, and then you break it down into its component parts. This time I'm going to give you the component parts. I'm going to give you all the zeros, all the values of x that make this function 0. And I'm going to ask you to find the function. All right. So I'm told that I have 3 zeros, 8, 2 plus 5i, and 2 minus 5i. So I put those zeros down. And now I want to really drive home this idea that if 8 is a 0, then x minus 8 is a factor, right? The factor is always x minus c. If you tell me a 0, I can tell you a factor of the polynomial. Now, this is a complex 0, so it's x minus c. And this, remember, c is the entire number, 2 plus 5i. Don't forget those parentheses on the inside, or it will not distribute correctly. Same thing down here, x minus 2 minus 5i. Turns out if you have complex zeros or irrational zeros, that the conjugates will always be zeros. So conjugate just means these two terms are added and now they're subtracted. That's the difference in them. These two numbers are called conjugates of each other. Everything's the same except for the operation between them. Okay, 2 plus 5i, 2 minus 5i. 7 plus I, 7 minus I. Those are called conjugates. And they always pair up. If you know one of the conjugates is 0, the other one automatically has to be. But let's continue the math. X minus all of that means I'm looking at x minus 2 minus 5i. And then I have x minus 2 plus 5i. Okay? So that means the polynomial that has these three zeros looks like x minus 8, x minus 2 minus 5i, x minus 2 plus 5i. Okay. Now, I'm going to make a slight change. I'm going to use the fact that multiplication is commutative to just swap the order here. I'm going to put x minus 8 way over there on the right because I don't want to do that multiplication first. And the reason is if I have conjugates, when I multiply them together, I'll end up getting rid of all the imaginary factors. All the i's will be gone, and that is going to be really helpful. So I want to do that first. So I'm just going to go old school. We're going to multiply these two trinomials. We're going to end up with 9 terms from this multiplication. All right, so it's going to be x times x is x squared. X times negative 2, negative 2x. X times 5i, 5xi. And then I go down to the next term, negative 2. Negative 2 times x, negative 2x. Negative 2 times negative 2 is 4. Negative 2 times 5i is negative 10i. And then lastly, negative 5i times x, negative 5xi. Negative 5i times negative 2 is positive 10i. And then negative 5i times positive 5i is negative 25i squared. And then don't forget the x minus 8 on the end. All right, now let's combine like terms. No other x squared terms in here. 2x and 2x, negative 2x and negative 2x are going to come together. Let's see if anything goes away first. Plus 5xi minus 5xi. Those zero out. The 4 does not. Negative 10i, positive 10i. Zero out. And then look right here. I squared is negative 1. So the reason that I multiplied the conjugates together is because if I did it, all of the i's would go away. Is that what happened? Yep. X squared, negative 2x minus 2 more, minus 4x. 5xi goes away, negative 10i goes away, that goes away, that goes away. And then I'm just left with negative 4x plus 4 minus 25 times negative 1. What's going to happen when I multiply 25 times negative 1? I'm going to get plus 25. So minus 4x, and then 4 plus 25, 29. All right, now let's finish it. Same process, distribute x squared times x cubed, x squared times -8, -8x squared. -4x times x, -4x squared, -4x times -8, positive 32x. 29 times x, 29x, and 29 times -8, 70, yeah, -232. All right, combine like terms, wherever they may be. There you are. X cubed, -8x squared minus 4 more, it's -12x squared. 32x plus 29x, 61x, and then minus 232 is just minus 232. So this is the polynomial that has zeros of 8, 2 plus 5i, and 2 minus 5i. All right. That's 2-3. Questions? Nothing? No? All right. All right. 2-3 is available. You can start looking at it. Yeah, that last page is just, it's old math, the stuff you've already done or should already know. This is the only new part. Yeah. This is the new part. If I give you the 0, you tell me the factor. But once we get to here, that's prerequisite knowledge, right? Multiplying those out is something you should already know how to do. So the only new part of that last problem, if this is a 0, this is a factor. That's the only new thing in this section. So don't let it overwhelm you. Don't think that there's so much more material in here, you're having to do so much work. No, it's old math. It's just a lot of old math. All right.